Live. Come on. We're live. Okay. 1, 3, 20. Yes, everybody else in the state is still on winter vacation, not us, but here we are. Anyway. Okay, so AI plus BJ. All these represents is taking a vector apart. This is the I-axis. This is the J-axis. And what we're going to do is just take it apart into its horizontal and its vertical component. Okay, that's it. So if I had a vector, AI plus BJ, it would look like this. You'd put both in. You'd put the vector here and the vector here. A would be just this length here, and B would be this length here. Now the resultant vector, V, would be there, okay? Sky's sitting in the chair. Morgan has one hand. Landon has the other hand. Where's Sky going to go? Here. But what makes this different is this is Landon's, or this is Morgan's force, is the A force, and this is Landon's force, the B force. That's all it is, okay? It's just taking it apart and showing both forces, okay? And in physics, we need that, okay? Now, how can you find the direction of a rectangular vector? Well, to do it, then to find the direction, you just rewrite it as a vector V is equal to my AI plus BJ. And if you need to find theta, right? If you need to find theta, it's just going to be the tangent inverse of the B over A. And that's going to give the direction, right? And tangent, because you can see that if you were to create a right triangle here, opposite over adjacent each of the angle, right? And I know I'm making sense. We've been doing right triangle trig since we were in geometry, right?
Wait, you wrote the J backwards.
I always do that, Landon.
Wait, no, maybe that's an I.
That's a J. That's
No.
an I, and that's a J.
Well, on the top of the
Yeah, that's, I do that. I don't know why I'm dyslexic on that. Okay.
Okay, that's an I.
Yep. And now the magnitude of AI plus BJ is still going to be the square root of A squared plus B squared. The magnitude is the length, right? I mean, it should make sense. Just new ways to look at it. So that's the force. The magnitude is the force, right? Or the speed, right? Now the dot product, okay? So write this down. Vector V is some x1, y1, and vector u could be some vector x2, y2, okay? And I'm just going to draw a picture. I've got vector u, and let's say I've got vector v, okay? The dot product. Now when I put this down, it's going to look like a time sign, but it's a dot. And write this down, it's going to look a time sign, but it's a dot, okay? So the dot product is this. It is going to be U dot V, because we don't multiply vectors. You don't multiply vectors. So what you get is you're going to take your x1 times your x2 plus your y1 times your y2. Okay, so as an example, we're going to say vector V happens to be 3, 2, and vector U happens to be, let's say, -2, 3, okay? Just as an example, okay? Because I want you don't know what a dot product is, why we would do this, okay? So if I were to graph these real quickly, okay? I've got 3, 1, 2, 3, 1, 2, and I've got -2 and 3, okay? Vector U and vector V. I'll slow down for a second. So I'm talking about this thing called the dot product. And what the dot product is as simple as this. It's that times that plus that times that. I'll show it again. It's as simple as this. That times that plus that times that. That's all it is. Okay? But what does it mean? If the dot product is 0, then the two vectors are perpendicular. I'll write that down, okay? So, if 0, if the dot product is 0, then they are perpendicular. Okay, then they're perpendicular, or 90 degrees. Okay. So this one, I did this one on purpose because they are perpendicular. You guys agree? They're definitely perpendicular. You guys see that? I mean, I know that this is 3, 2, -2, 3. They're going to be 90. Okay, but let's check it out on the dot product. So dot product is going to cure that. Okay. So on this one, if I go my u dot v, I'm going to go and get a 3 times a -2 plus a 2 times a -3. Oh, gosh. Nope, yeah, that's positive. Hold on, I made a mistake. Oh, 2 times +3. I did make a mistake because I had to come out 0. x1, x2 plus y2, y1, y2, and so I get a -6 plus 6 equals 0. Now, if the dot product is 0, then we know that they are perpendicular. So that's 90. Okay. If it's 0, and if it's not 0, what does it tell us? It's not 90. Okay. So dot product. If the dot product is 0, perpendicular, and that's super important in physics. You know why it's important in physics? Because of gravity, right? Gravity's always going down, right? And if the force going down is perpendicular, right? Then that's important because we live on Earth and we've got gravity. Okay? Now, what if it's not 0? We can still find the angle. So, if we want to find the angle between two vectors, let's say the two vectors are not, then we're going to go cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. And then, of course, we'll cosine inverse that because we're looking for the angle. Then we'll go cosine inverse of that answer, okay, because we're looking for an angle, okay? And we're going to do that example on our notes, okay? So now let me keep passing out the notes, okay? There's our reading. So let's take a look at our notes, okay? So far, so good? Okay, you guys, everybody have that formula? Okay. All right. So let's take a look at this. So vectors are not difficult. I don't think you guys can find this hard. Not as hard as like trig identities. Remember trig identities? Remember last test? How bad last test was?
Yes.
The test before last test? So this is easy stuff, huh? You guys agree? We're finally on some easy stuff. Sydney, you gonna sit? Oh, I'll sit back here. Okay. So we're gonna do some easy stuff. Isn't that nice to know?
What are you looking
Just like it.
at? Oh.
Yeah.
That's rough.
All right. So let's take a look at our notes. Everybody have notes? Okay. And Patricia, you want to borrow my here? Patricia, you want to borrow that? You can borrow it. Yep, you're welcome. Okay, here we go. So today, what we're going to do is talk about what we call rectangular vectors and the angle between vectors. Okay, when we say rectangular vectors, that's our AI plus BJ. They call it rectangular because the reason they call it rectangular is because they'll call the graph. There's several names for this thing. Several names. One is the XY plane. The other is the Cartesian coordinate system. Have anybody ever heard that name, Cartesian coordinate system? It's just called that because this dude named Descartes decided to create it. And the other is called the rectangular grid, okay? So it's all the same thing. It's basically the XY plane. So, all right, example 1. Draw PQ with these 2 points. So first I'll go and I'll take 2, -6, 2, -6, 1, 2, 3, 4, 5, 6, right? Oh, shoot. I want, nope. That's, put that there. Shoot, doggone it. I just want a point. It's not a vector PQ. Do you see what I did wrong? This is a point, not a vector. Okay, there's P, and then Q is at -6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, there is P and there's Q. Right? And I'm going to try and draw this in. I need a ruler. Here we go. Darn it, I hate it when I make mistakes. All right? There it is. Now, let me ask you an easy question. What's wrong with that vector? Let's bring it to the origin. Okay, can we just bring it to the origin? So to bring it to the origin, we want to make it a component, okay? So we're going to make it a component, let's bring it to origin. So yesterday was all about drawing these. Today's about the math. Okay, so check it out. I could physically pick it up and bring it. Or I could take x2 minus x1 with y2 minus y1 will put it to the origin. Does that make sense? So if I take my negative 6 minus 2 and then my 6 minus a minus 6, I'll get its component vector, which is going to be at negative 8, 12. So if I were to take this darn thing and move it,
Wait, isn't it negative 2?
yeah, double negative, that's why I added it. Right?
I don't know.
Right? So if I were to move it, guess what? It's going to be like this. And the coordinate of this point is at negative 8, 12. So instead of physically moving it, you can do it mathematically. So actually trying to pick this darn thing up and move it, all I do is if I subtract the x's, x2 minus x1, y2 minus y1, I subtract it, and I wind up with the answer without even having to graph. Okay, does that seem easy? Okay. Now, example 2. It's in rectangular form. How do I know it's in rectangular form? It's because of the I and the j. Okay, so first of all, let's just go ahead and lightly graph them both. So I'm going to go ahead and do for this one, I'm going to go here and here. Here's my V1, but it's really right there. Right? So I've got my 2i as my horizontal, minus 3j is my vertical, but the vector itself is here. Now, V2 is going to be like this. It's going to be my 4, 1, 2, 3, 4, and 5, 1, 2, 3, 4, 5, right? And it's really going to be right here. So if I wanted to add them, I can just set up my parallelogram method. Okay, watch my parallelogram method. See, I made a parallel. Do you see the parallelogram I made? See, I made a parallelogram. And then the resultant vector is there. Let's do it the hard way. Hopefully somebody saw, oh, Mr. Davies, why don't you just, come on now, why don't you just do what? Why don't you just add them? And I would have gotten the blue line just by adding them, because I wanted to show it to you visually, but what happens is really, it's as simple as this. V1 plus V2 is just simply going to be V1 plus V2 is simply going to be, ready? 6i plus 2j. Let's see. 1, 2, 3, 4, 5, 6. 1, 2. What do you know? Why do I do both? Because in physics, you got to be able to see it. Does that make sense? Physics, you got to be able to see it. The numbers mean nothing if you can't see it, okay? So there's a visual of Morgan pulling, Landon pulling. This is Landon's vertical force. This is Landon's horizontal force. This is Morgan's vertical force. This is Morgan's, ignore that. So together, this is where sky goes. We got that? Okay, now, example 3. Write a rectangular vector if the magnitude is 7, the direction is 135. So I'm going to draw a picture. Okay? So I draw a picture. Oh, it's probably Diana. It's probably Diana. Okay, so here's a picture of what's going on. Do you guys agree with that? Magnitude is 7, so the length is 7, and the direction is 135. Okay, so if we want a rectangular vector, we got to find the x, and we got to find the y. How do we do that? You know that. You do know that. How do you find the x and y? You do know that. Help us out, Evan. Come on, you guys know how to do this?
7 cosine 135.
Thank you, Sky. And?
7 sine.
Yes, yes, hooray, somebody can do this. Calculator, degree mode, right? Calculator, degree mode, calculator, degree mode. Here we go. Check my phone. Oh, here it is, Diana. Oh, it's a robocaller. Darn, I missed that one, huh? I thought the Trump administration was trying to help us by cutting back on this stuff. We'll see. All right. 7 cosine 135 negative 4.95. 7 sine is a positive 4.95. So, you ready? Let's look at the question. We need a rectangular vector. So we need it to be this. We need V to be some AI plus BJ. Rectangular vector, right? So my rectangular vector is V is equal to a 4.95I minus a 4.95J. Okay, so think about it. This is the force you're pulling horizontally. And this is the force you're pulling on it. Yes, I have this wrong. Minus, come on you guys, plus, there we go.
Oh, well, I thought.
No, I did it. This is, no, you were right.
I changed it.
Because as soon as I said pulling, I'm like, wait a minute, I'm pulling backwards, right? And so I said pulling up, I go, wow. You see me pause for a second, I'm going, wait a minute. Okay, easy? If I can just get it right. Okay, turn the page. All right, now, the dot product, okay? So how do you do the dot product? Super easy. So V dot W is equal to, you ready? A 2 times negative 3 plus my negative 3 times 4, okay? Which is negative 6 minus 12, which is negative 18. So what? What does that number mean? It means nothing except for one thing. This number means nothing except for one thing. It's not perpendicular. That's all it means. Does that make sense? So it's not perpendicular. Some other angle, right? So example 5. Okay. Let's go P dot Q. I meant for this to be perpendicular, but I was in a hurry, so that's okay. I'll go back and fix it for next time. We're going to go 5 times negative 3 plus 12 times 4, negative 15 plus 48, which is what, 33? Is that 33? I think so, 33. Okay, so what does that tell me? That's all it tells me, not perpendicular. So it tells me not perpendicular. But what if I do want to know the angle between those? So just a real quick graph. You don't have to graph these, but just out of curiosity, if I did graph these, I've got my 5, 12. It looks something like this. Negative 3, 4, something like this, okay? So here's my angle. Say it again, Sydney. What do we know about that angle?
It's not.
So it's not 90, right? But what is the angle? Well, here's how you do it. We'll go cosine of theta equals, you ready? P dot Q, which we know that answer, 33. We know that answer, right? Divided by the magnitude of P times the magnitude of Q. Now the magnitude is the length. The magnitude is the length, which is Pythagorean's theorem. So let's do a little side work here, okay? So my little side work is, let's see, let's find the magnitude of P real quick.
So will you just take 5 squared plus 12 squared?
Yep. And that's 13, but you can go ahead and double check. It is 13. I gave us nice numbers, okay? And what is the magnitude of Q? Well, okay, let's just do that. Again, it's basically the length of Pythagorean's theorem, so it's going to be negative 3 squared plus 4 squared, and that, I gave you nice numbers, that's just 5. Okay, trust me, if you want to do the math, right? So let's finish this up. So if I want to find the angle, I'd go cosine of theta equals, let's see, I'm going to go 33, because that's my P dot Q. We found that up here, right? Divided by the magnitude of P, which is 13, times the magnitude of Q, which is 5. So I have cosine of theta equals 33 over 65, right? What do I have to do if I'm looking for the angle? Inverse. So what is cosine inverse of 33 over 65? I don't know. That's what calculus is made for, right? Okay, so clear cosine inverse of 33 out of 65, and I get an answer of about 59.5 degrees. And it is not perpendicular, is it? It's not 90 at all. Okay, that's what I have. So we don't have a ton of time. We've got enough time to get some of this homework done.